बच्चों, today we are going to start solution, a chapter of plus 2 CBSE and different boards. So in solutions, today we are going to discuss in part 1, that is, first is definition. So what is the definition of solution? Definition is, solution is a mixture of two or more non-reacting components. So here we have to learn one thing, that we have to require a non-reacting one. Non-reacting in the sense, basically they cannot react with each other, and that is two or more. If there are two components used to make a mixture, then this solution is known as binary solution. And if there are three components, then it is known as ternary solution. But in our syllabus, we only include binary solution. We only include binary solution. We only include the binary solutions. Now, first we can discuss about the classification of solution. So it is classified on the basis of type of solvent. On the basis of On this basis, the solutions are of following three types. Solutions are of following three types. Solid solution, which are physically present in solid state. Liquid solution, which are physically present in liquid state. And gas solutions, which are physically in the gaseous state. Now we first discuss about the solid solution. These are further classified into three types, that may be solid in liquid, solid in solid, liquid in solid, and gas in solid. If we want to know the examples of these all, that's number one, that is solid in solid. The example is alloys. We know that alloys are the mixture of metals like copper and silver and so. Liquid in solid, normally basically that is crystalline water, like if I say copper sulfate dot 5H2. So this water is in the crystalline form. Gas in solid, the example will be, a simplest example is foam, because the foam is solid in which air gaps are present, in which basically we can say the gas will be present. Now liquid solutions, they are again of three types: solid in liquid, liquid in liquid, and gas in liquid. If I ask you the examples of these all, if you see that solid in solid is solid in liquid is 99% examples are these, like salt in water. Liquid in liquid is alcohol in water, because we know that alcohol is soluble in water. And third one, gas in liquid is that is cool drink or soft drink. This is gas in liquid. Now we move on the third one, that is gas solutions. Now these solutions are again of three types. That means solid in gas, liquid in gas, and gas in gas. For the example, solid in gas is dust particles in air. Liquid in gas is fog or moisture, and gas in gas is air, because air is a mixture of different type of gases. So this is the basic classification of the solution, in which we can classify the solution on the basis of the type of solvent or on the basis of their physical state. Then on the basis of concentration, basis of concentration of solute in solution, in this basis we can classify the solution into two categories: dilute solution and concentrated solution. What is the meaning of dilute solution? It's very easy. Dilute, in which the concentration of solute is lesser. Concentration of solute is less, and here the concentration of solute is more in same amount of salt. So this is the first thing we have discussed in this chapter, that is, first is the definition of solution, and second is the classification of solution. Now after these 2 points, now we are moving on a third point. The third point is basically concentration of solution. Concentration of solution means that how much amount of solute is present in given amount of solution or a solvent. There are different ways to express the concentration. First is percentage composition. It is divided into three types, that is percentage by W by W or percentage by mass. Second is percentage weight by volume, and third is percentage V by V or percentage by volume. This is a very simplest way to express the concentration. In percentage, weight by weight, it is defined as weight of solute. We always express the weight of solute in grams upon weight of solution in grams into 100. Weight by volume is weight of solute. W stands for weight and V stands for volume of solution. At the top we always use solute, and denominator we can use always a solution, that is solute over solution into 100. And third comes percentage V by V, means volume of solute in ml upon volume of solution in ml into 100. Now we can do some questions to understand these three terms. No doubt these three terms are nowadays not more important in chemistry, but in the pharmaceutical industry this is a very common way to express the concentration. If you see any medicine, so in medicine the composition is expressed in weight by weight or weight by volume or volume by volume. Like I can give you a question, 2 gram NaOH is dissolved in water to make 500 ml or 500 cc. One thing understand, 1 ml is 1 cc or 1 centimeter cube. This is the same thing, beta. Now 500 cc solution, and when the volume of solution is given, then we have to mention the temperature also at 298 Kelvin. Find percentage weight by volume concentration. So it is simple that the weight of solute given is 2 gram. Volume of solution is given 500 cc. So percentage weight by volume is very simple, that is 2 by 500 into 100. That means 0.4%. Did you got it, Peter? Now if in the same way I can give you the another question. The question is that 2 gram NaOH dissolved in water to make 200 gram solution. Having density 1.2 gram per cc, then find percentage weight by weight and percentage weight by volume concentration. So here we have just changed it into the two terms, so it's easy to be expressed like the weight of solute is given 2 gram, weight of solution is 200 gram, and here we can use another term, we can find volume of solution. And you know in the lower classes that density is equal to mass upon volume, so volume becomes that is mass upon weight upon density. So here it becomes 200 by 1.2 cc or ml. Now percentage weight by weight is a very easy term, that is 2 by 200 into 100, that comes 1%. And percentage weight by volume, for this we put the weight of solute upon volume of solution, that comes 200 divided by 1.2 into 100, so it comes 1.2%. I think you got it. But from here we can get the one important data, that is how can we give the relation between, that is important for you all guys, between percentage weight by weight and percentage weight by volume. See beta, here basically we know that percentage weight by weight is weight of solute in grams over weight of solution in grams into 100, and we know that weight of solution is volume of solution into density. So we replace this term here, so it becomes weight by weight percent is equal to weight of solute in grams over volume of solution in ml into density into 100. So this weight by volume is known as percentage V by V. So we can replace it, percentage weight by weight is equal to percentage weight by volume over density. So this is the relation we got, percentage weight by volume, and this is a very important relation in your term, into density. I think so you got it. After this we can move on. The next one is, that is molarity, because percentage V by V is not so many common. We can do one question, that 2 ml acetic acid is dissolved in water to make 50 ml solution at 298 Kelvin. Find percentage V by V concentration. So it is very easy, that percentage V by V is equal to 2 by 50 into 100, that comes 4%. Third, the important concentration, second, the concentration term is molarity. First is percentage and second is molarity. Simply, molarity is represented by a capital M. It is mole per liter or mole per decimeter cube. See, 1 ml, before we can go ahead, 1 ml is known as 1 centimeter cube or 1 cc, and 1 liter is equal to 1 decimeter cube. dm cube is a decimeter cube. So molarity means moles of solute. We know that moles do not have any unit, upon volume of solution in liter or decimeter cube. So basically here we can say moles, we can find weight of solute in grams upon molar mass into volume of solution. If it is an ml or centimeter cube, then we can divide it by 1000 to make in decimeter cube. So this is the complete formula of molarity, and here unit may be mole per liter or mole liter inverse or molar or capital M. So these are the different way to express the molarity. We can do some questions on this one. I can say you that 8 gram NaOH dissolved in water to make 100 cc solution at 298 Kelvin. Find percentage weight by volume and molarity. So here basically weight of solute NaOH is 2 gram. Molar mass of NaOH, how can you find it? It is very simple, that you can add 23 for sodium, 16 for oxygen, and 1 for hydrogen, it becomes 40. Then we back that is volume of solution. It is 100 ml or 100 cc. So percentage weight by volume is very easy. That is 2 by 100 into 100. That is 2% weight by volume. And for molarity, weight of solute is 2 gram upon 40 is molar mass, 100 ml is solution, and to convert into decimeter cube we can divide it by 1000, so it becomes 0.5 molar. Here what we can do, the next thing, we find the relation between percentage weight by volume and molarity. How we can find it? See, molarity is weight of solute in grams upon molar mass into volume of solution in ml into 1000. And out of these, if you can find it in a simple language, that weight of solute upon volume of solution into 100 is called percentage weight by volume. So molarity becomes percentage weight by volume into 10 upon molar mass. And one more thing, that percentage weight by volume which we have derived above is equal to percentage weight by weight into density. So we can use this relation to give the second important relation, that molarity is equal to percentage weight by weight into density into 10 upon molar. So these are two important shortcuts, that these two formulas are very important to learn. Like if I can give you, find molarity of 2% weight by weight solution having density 1.2 gram per cc. So how can you find it? It is molarity equals to 2 into 1.2 into 10 over 40. So it becomes 0.6 molar. It's too easy to be just expressed. Within a second you can find the molarity from the different concentration terms. Then the next term comes, the third one is, before it we have studied percentage weight by weight, weight by volume, and volume by volume. This is the first thing. Second is molarity, and now we are moving on a third one, that is normality. For normality it's very easy. We have to be discuss normality equals to molarity into valency. How we got this? The complete formula we are using on the next page, that normality is equal to weight of solute in grams into 1000 upon volume of solution. These three terms are altogether same that given in the molarity, but instead of molar mass we are using equivalent mass here. And what is equivalent mass? Equivalent mass is molar mass upon valency. Valency is an n factor. So simply normality you have to be learned by this formula, that is this one. How can we find the valency? That's a next term. See, if we, in case of acid, valency is equal to number of removable H plus ions, that is basicity of acid. acid. For example, HCl, it gave 1 H plus, so its valency is 1. For H2SO4, its valency is 2. But the important examples you have to be learn is H3PO4, H3PO3, and H3PO2. Their valencies are little bit weird, typical to be just learned, that is 3, 2, and 1. How we can find? We can find this from the structure. In H3PO4, all the 3 hydrogens are attached to more electronegative oxygen atom. In H3PO3, only 2 hydrogens are attached to more electronegative hydrogen atom. And in H3PO2, only 1 oxygen is attached to the more electronegative oxygen atom. So in case of H3PO4, all the 3 oxygens are removable. In H3PO2, only 2 oxygens are removable, and in H3PO2, only 1 hydrogen is removable. So it clearly explains the valency of H3PO4 is 3, H3PO3 is 2, and H3PO2 is 1. Understand? Now the next term, the fourth one, is molality. It is little bit weird, different from the molarity. It is represented by small m, and molality is called mole per kilogram. So simply we can define molality is a weight of solute in grams upon weight of solvent. So this is the only term in which we are using solvent instead of solution in denominator. So sorry, it's moles, not weight. So moles of solute per kilogram. So how can we find out the molality? It's very easy. That is weight of solute in grams upon molar mass into 1000 over. This I am making with a different color. That what is the difference from molarity? Is the weight of solvent. Now 1000 is used, so we can use in grams. So this only term is different in molality from molarity. Got it? Then the most important term which we are using in this particular chapter more, that is mole fraction. So mole fraction is represented by X. Mole fraction, we can add Na moles of A and Nb moles of B. So the mole fraction means hissa, that is moles of A upon total moles. And total moles. And always learn one thing: the sum of the mole fraction of all components present in the solution is always 1. Now we can do some questions to find out it. We have given 0.2 moles of ammonia is dissolved in 18 gram water. Find its molality and mole fraction of ammonia. So how can we perform this question? That moles of ammonia or moles of solute ammonia is 0.2. Weight of solvent water is 18 gram, or moles of solvent is 18 by 18, that is 1 mole. So first of all, molality is moles of solute over weight of solvent into 1000, that comes 100 by 9 molal. And for mole fraction of ammonia, that is moles of ammonia 0.2 over total moles, that is 0.2 plus 1, that comes 0.2 by, got it? So these are the some important concentration terms which we have discussed in this part 1 of the solution chapter. In the next chapter we can discuss about the solubility, Henry's law and the Raoult's law. So we can split the chapter into 3 or 4 classes. So this is the first class in which we have discussed, that is number 1 is a definition number of solution, number 2 is the classification of solution, and number 3 is some important concentration terms. So bye now, and for any further doubts you can just mail me. My mail ID is rahulcam. So for any doubts or further queries you can comment me. Thank you. Bye bye.